Good morning, everyone. Can you hear me, all of you? Yes, sir. Okay, okay, okay. Only 20 students are present. Wait for 1 minute, okay? Okay, so can you see the screen, all of you? Can you see the screen?
Yes, sir.
Okay, okay. Okay, so in the last class we were discussing about the design of singly reinforced beam by limit state method. Okay, so today also we are going to do the same. So I have shown you in the last class. I have shown you some examples from my which book I was using. So now I will show you one example from YouTube also. So you just go through the procedure, and one thing I will tell you after the example will be finished. You have to do for the deflection part also, and shear reinforcement also you have to design here. Okay, so in this example which I am going to show you now, in this example they will just design the beam. That means they will find out the dimension of the beam, and they will just find out the area of steel. But what you have to do after doing all this, you have to find out, you have to design the shear reinforcement, and also you have to check for deflection. Okay, so the remaining part is up to you. I will tell you how to do it, but first you just go through the example. Okay. Okay, so let's see the example. Okay, so this is the question. Design a beam of span 4 meter to carry a UDL of 25 kilonewton meter, and you have to use M20 concrete and Fe 415 steel. Okay, so first you have to write down the given data. Clear span is given, UDL is given. Okay, then we have to check the depth and width of the beam. Okay, L by D ratio they have assumed as 12. It should be 10 to 17. Okay, so there they have assumed L by D ratio as 12. So L is given 4 meter. So if you assume, okay, so if you assume L by D ratio is equal to 12, you can find out the effective depth, which they have got 333, but they have approximately assumed as 400 millimeter for doing the calculation easily. Okay, you can assume it this D effective as 350 millimeter also. Okay, you can assume this D effective as 350 millimeter also. Okay, so then you can see the width will be approximately 1.5 to 2 times of the, you can see here D by B ratio is approximately 1.5. So if we assume, okay, see here, after getting the value of D effective, then we have to find out the width. Okay, and D by B ratio is, they have assumed as, it should be approximately half to 2 by 3. B by D ratio, it should be half to 2 by 3. Okay, so D by B equal to 1.5. Okay, so we know the D effective, they have assumed 400. So D will be 400 divided by 1.5. So they have got as 266.67. So for easy calculation, they have assumed B equal to 300 millimeter. Okay, so now these are just assumed values. Okay, so after doing the calculation, we have to check whether our assumption is correct or wrong. We have to check that after doing the calculations. Just like the previous last class problem, where in the first problem we have assumed the width and the depth of the beam, and then after doing the calculation we have to check whether our assumed values are correct or wrong. Okay, so next, just see the calculation. Provide nominal cover of 50 millimeter, d dash equal to, okay. Therefore overall depth will be equal to d plus d dash, 400 plus 50, it will be 450 millimeter. Next, we have to find out the effective length from clause number 22.2. As I have shown you in the last class, we have to use clause number 22.2 for finding out the effective span. Okay. For doing that, we have to find out two values: clear span plus effective depth, and a center to center distance. Okay. You can see here, first one is clear span plus effective depth. Clear span is given 400 millimeter or 4000 meter, and we have got effective depth is equal to 0.4. It is 4.4. Okay, and center to center distance will be, okay, and in the question I think the width of the support is given. Width of the support is given. No, it is I think width of the support was given 230 millimeter. Yeah, so center to center distance will be 4.2. Therefore, we have to compare these two values, 4.4 and 4.2, and we have to take the minimum value as your effective span. Okay, yeah, you can see here, taking less value, effective span will become 4.23 meter. Therefore, next we have to find out the design moment. First, find out the gamma concrete means self weight of the concrete. We have assumed this as 25, okay, but in this video they are taking it as 24. According to IS, it is 25. Then we have to find out the factored moment or design moment. It will be WL square by 8. So therefore, after that, we have to find out the moment of resistance. Okay, so moment of resistance, this is the formula I think I have shown you, not in this chapter. Before I have told you how to find out this value, because in this question, your grade of steel is given and grade of concrete is also given. So if you are using Fe415 and yeah, and your XU will be, XU max will be 0.48D, okay, from clause number 38. So if you put all the values in the actual equation given by IS 456, you will get the moment of resistance for this grade of steel and concrete. It will be 0.138 FCK BD squared. Okay. So you put all the values. since the moment of resistance is greater than okay, so can you all see the screen, all of you? Can you see the screen, all of you? Okay. So now as the beam is designed for under reinforced, why it is under reinforced? Because you can see here, we have got the design moment is 94.75 and this is mu lim, okay? Limiting moment of resistance. This is 0.138 FCK BD square. So you can compare the values. The design moment is less than the limiting moment, okay? So mu is less than mu lim. Okay, so here it is, he has written it wrongly. It should be MOR moment of resistance. It should be written here limiting moment of resistance is more than it should be mu design moment. Okay, this line is wrong. You can write design moment mu, since design moment mu, this value was mu, this 94.74, mu is less than, and this equation you can write mu lim, okay, means limiting moment of resistance or maximum moment of resistance. Mu is less than mu lim, therefore the beam will be designed as singly reinforced. Okay, the beam will be designed as singly reinforced. Okay, so now for singly reinforced beam, you can see here everything is written here, page number 96, NXTG, everything here is written. So from this page number, you will get mu equal to this equation. Okay, moment of resistance for this kind of beam is this one. Okay, so in this equation, all the values are known except area of steel. So mu is known, this is 94.75 design moment. Fy is known, 415, because grade of steel is 415. D we have already calculated, and in this part also all the values are known. Fy is known, B is known, D is known, FCK is known. Okay, so if you solve this equation, you will get the area of steel as this much, 754.418. Okay, so now after getting the value, if you choose the diameter of bar as 16 millimeter, so you can find out the number of bars. Total area divided by number of one bar. Total area divided by area of one bar, you will get the total number of bars. Let's see how much we will get. Total AST by AST of individual. Okay, so 4 numbers. We have got 4 number of 16 mm bars are required. Therefore, AST provided will be 804.2 millimeter square. Okay, so next, after finding out the value of area of steel, what we have to do, we have to check whether we have provided the minimum amount of reinforcement or not. Okay, and whether we have provided okay, so your provided reinforcement must be more than minimum amount of reinforcement, it must be less than maximum amount of reinforcement. Okay, so let us see how to check it. Okay, so the minimum amount of reinforcement was given by a formula. You will write everything here, page number 46, 47, clause number 26.5. Yeah, tension reinforcement. This is the formula. This is the formula. by which we can find out the minimum amount of reinforcement. This is the equation. Okay, this is the equation. So AST minimum equal to 0.85 BD by FY. So let's see how much minimum reinforcement was there. Okay, so you can see here minimum reinforcement required was 245.78 and we are providing around 824. That means our calculation is correct. Okay, and let's see how to find out the maximum amount of reinforcement. Maximum reinforcement. Okay, 4% of gross area. 0.04 BD, 0.04, we put all the values. You can see maximum amount of reinforcement is 5400 millimeter square, but we are providing how much? It is 804.24. That means our provided reinforcement is more than the minimum amount and less than the maximum amount. Okay, so that means our calculation is correct. Okay. So now tell me till this part, if you have any doubt in any step, if you have any doubt, you ask me. If you have any doubt in any step in this question, you ask me now. If you have any doubt in any step in this problem, you can ask me now. Can you hear my voice, all of you? Can you hear my voice? Can you hear my voice? Okay, so now you tell me if you have any doubt. Anyone have any doubt in this problem? Because this problem is not yet finished. Okay. Okay, so I am asking you if you have any doubt, you can ask me, but no one is responding. Shiroda?
Sir,
Okay, so you tell me whether you have any doubt in this part.
I don't know.
You don't know. Okay, okay. Because this problem is not yet solved completely. Okay, okay. Because after finding out the area of reinforcement, we have to design the shear reinforcement also, and also we have to check for deflection.
Sir, please send this YouTube link after class.
Okay, okay. Okay, so do you have, okay, so let's see. Okay, I will show you the last class video. Wait, I will show you the PDF. Okay, and one thing, what to say, one information or notification, whatever you say, one thing I have to say, I have to tell everyone that uh, you have to attend the your practical classes physically. Okay, as soon as possible, you have to come and you have to attend the lab classes physically because it has been told to us that we have to conduct laboratory classes physically and all the students must be present there. Okay, but regular theory classes they haven't say anything till yet, but for practical classes we have to conduct it physically, means you have to be present during the class. Okay, so give us a date. Actually, now I can't give you a date because immediately, they say immediately means you ask your mentor. Okay, you do one thing. Okay, so I will give you our coordinator number to you, and the CR you call him. Our coordinator name is, I think you know him, Rituras Nath. Okay, so you call our coordinator sir, and you ask him that we have been informed that we have to come and attend the laboratory classes. So can you give us a date? Okay, can you? And actually, all of you know that your classes cannot be finished in a single day. Okay, because a lot of groups are there. In section A, two groups are there. Section B also, two groups are there. And you have five, I think five labs. Your hydraulics lab will be there, soil mechanics lab will be there, environmental lab will be there, then transportation lab will be there. Okay, and concrete lab will be there. So, okay, I think you have four or five lab subjects, laboratory subjects. So, and in every lab, you have to conduct at least four or five experiments. Okay, so it cannot be completed in a single day. So I will give you the CR number, our what to say, coordinator number to your CR. That means I will share the number to Shirodha. So you call him today only. By today only, you call him and you ask him that we are informed to come and attend the physical class, laboratory classes. So, sir, please give us a date from which we can come and attend the regular laboratory classes. Okay. Otherwise, after some time, if you don't come and attend the lab classes, then it will be difficult for us to conduct the lab exams. Okay, since we have to conduct our laboratory exams, and I think this time it might be conducted physically. Okay, because in Assam, I think you know that if someone from Assam is there in your section, they will know that situation in Assam is quite good now, because all the schools and colleges are open. So our university will also be open very soon. Okay, so you ask him and you take a date from him. Okay, So you do it by today only. You do it by today only. Okay, so just after the class I will share the number, and you just call him and you ask him about this. Okay, this is the responsibility of your CR. Okay. Okay, so let's go to the last class, numerical. Okay, so just now whatever problem I have shown you, you can see here. I will share the note to you just after the class. This one also I will share with you, that in this question, in this example, in this YouTube video, you have seen that they have assumed a suitable depth to width ratio. You can see here this ratio should be around 12 to 1 by 12 to L by 12 to L by 15. You can see here. Here you can see this value, L by 12 to L by 15. So in that video they have assumed as L by 12. That means if values are B and D value is not given, and the clear span is given, okay, so in that case we have to assume a value between L by 12 to L by 15 as the depth of the beam. You can see here the depth of the beam can be assumed as L by 12 to L by 15. Okay, so after getting the depth, you can see here the width of the beam can be taken as 1 by 2 to 1 by 3 of the depth. So if you have got the depth of the beam as 500, you can take the width of the beam as half of the depth or 1/3 of the depth. Okay, so if you assume half, then it will be 250, and if you assume it as 1/3 of the depth, then it will be 1/3 into whatever depth you will get. Okay, so in that problem I think they have assumed as half. Okay, so this is the procedure. Then we have to calculate the self weight of the beam. You can see here this procedure has been followed in the problem I have shown you in the YouTube. Exactly this procedure has been followed. Okay, but one thing, they didn't check this step in that video. This step is skipped. This step has been skipped, but for exact calculation or for correct answer, we have to check whether our assumed depth is correct or wrong. Okay, this step has been skipped in that problem. That means after assuming the depth, they didn't check whether our assumed depth is correct or wrong. Okay, I think that person has already checked this depth before, but in that video he has skipped that step. Okay, but in our calculation we have to show it whether our assumed depth and width are correct or wrong. Okay, so then after doing this, after getting the dimension of the beam, we have to find out the area of steel. Okay, and then we have to find out. Okay, so in that problem they have calculated up to the moment of resting. That means up to area of steel they have done. Okay, so now you can see here, if only design of flexure is required, then up to step 5 is required. Up to this is our step number 5. Okay, in the step number 1, what we will do, we will find out the design bending moment. Okay, if mu is not given, if bending moment is not given, we will find out mu, that means design bending moment, by assuming width, depth, these things. After doing all the calculations, we will find out the design bending moment. In the second step, we will find out the xmax by d from this table, and we will find out the value of Ru. Next, we will find out the d required. That means we will check whether our assumed depth is correct or wrong. Okay, 3 and 4. And then we will, in step number 5, we will find out the area of steel. So these are the 5 steps which in every problem you have to do. But you can see here in the note it is written that if only design for flexure is required, then follow up to step 5. But if full design of beam is required with all the checks, then do 6, 7, 8, 6, 7, 8 and 9 steps also. That means if you are asked to find out, design the beam with all the necessary checks, that means you have to first design the beam, then you have to check for deflection, you have to check for shear, okay, and you have to finally give the design summary. Okay, you have to do all the steps. But if only it is said that design the beam and some datas are given, then up to this step it will be finished. Up to area of steel you can find out and your answer is complete. Okay, so now In the last class also, one problem I have shown you where we have calculated the deflection, how to check for deflection and how to find out the shear reinforcement. Okay, so I will show you again here because this step is very important in every problem, because you might ask to find out for, you can see here this question. This question has been solved in the last class. You can see here it is written that design the beam with all the necessary checks. That means after designing the beam, we have to check whether our beam is safe for deflection or not, whether we have provided the necessary shear reinforcement or not. These things we have to check here. Okay. So I will explain that part again here in this problem. I hope all of you can find out up to area of steel. Area of steel and number of bars. Okay. It is very easy. Okay, so now here again I will explain this part. Check for deflection, because this is a very important part. Without understanding this part, you cannot complete the problem. Okay. Now, based on this problem, okay, wait, I will share the PDF with you, then it will be better. I will share the PDF with you in the group, then I think it will be better. Okay, so I have shared the PDF with Shiroda and your common CR group. Okay, okay, so all of you do one thing. You open the PDF and you take your IS456 with you, because without IS code you cannot solve this part. Okay, without using the IS code, you cannot solve this part. Okay, so I will close this class now, but you join again at 10:30. Okay, now it is 10:23. You join again at 10:30 with your IS code and with this PDF. Okay, and I will explain it thoroughly, and we will try to solve another problem. Okay, we will try to solve another problem. Okay, so thank you. All of you join again at 10:30.